Hi teacher, here I show you my 5 Arduino practice exercise. I'm going to divide this video into 5 parts so you can see what minute each practice begins. So now I'm going to explain the first practice. First, we go to MCC and set the CPU to external clock exactly on 16 million hertz, and then we have to select the ports B and D to 0 to 5 each one, and next we need to generate this code. So for this it can be sent to the microchip and we can begin programming here. The test, the practice requires that we modify the port B so that when it is read, a constant is added to it and displayed on port D. The constant will be the result of adding all the numbers of my license plate. In my case, um, will be the number 6. Well, if the constant is greater than 64, it cannot be reflected in the output port. So here we reflect that port B will be equal to port D, only adding the 6 more at the end. And finally, we add an if that indicating that if port B is greater or bigger than or equal to 64, port D will equal 63 with a delay time of 10 milliseconds. Let me only change this for the Proteus. We load the code here to confirm that there's no problem or something. Okay, and now we go to Proteus. Here we will use the Atmega, this Atmega 328B, a deep switch, and 6 LEDs with one resistor, sorry, in each LED. By right clicking on the Atmega and editing properties, we have to add the archive with termination point elf exactly on the user account and documents. Now we have this. You click on OK, and finally you check the simulation. Okay, so every time you press the deep switch, the LEDs will display an increment of 6 in binary code. You see, if all deep switches are off, the LEDs count 6. If I switch one, the LEDs count 7. 3 counts 10. 9, sorry, counts 9. And if I all or almost all, the LEDs will be steady in 63. Okay, now let me show the physics practice. In physical form, it will look like this. If all the switches are off, the LEDs will be displayed at 6. If I turn the switch to 1,
this they will display at 7. If I turn the switch to 3, they will display at 9. And if I exit all the limits, all the LEDs will still light. Okay, this was the first practice. Now I'm moving on to the second.
In practice 2, we're going to create an ascending and descending binary counter using two push buttons. To do this, we'll go back to the MCC in a new microchip project, and we'll leave the same external clock and the CPU here, and we'll select the ports B, only the 01 that will represent the bottoms, and for ports D we'll select all ports to 0 to 7 in output. Okay, the buttons on input and the port D all output. And only we simply specify the name of the bottoms. See? Yes, okay. And we program the code here. We'll generate and return to microchip. Here, the first thing we'll add is an array called a counter, this, okay, which will do all the binary numbering, okay. Then we add the if statement that says if the first button get a value not equal to 0, that means it activate, the counter will be increased 1, and this will be reflected in the port D. Okay. The same will be done with another button, with the difference that the counter will be decreased. Okay, and also reflect to the port D. Okay, let's program this. If we not have fail or skips or warnings, we'll go to the protests. We program here. Okay, we program the code the same form. We have the same things with the Atmega and the 8 LEDs. Now our 8 LEDs connect to ports D, but with the difference that there are two push buttons in the port B0 and port B1. That one will be increased and the other will be decreased. Okay. We say the properties and select the archive. Now let's simulate this. Okay, according to the code, if we press the top push button, the counter will increase, and if we press the other button, the counter will decrease. Okay, and if we continue decreasing, the counter will reach the highest number. Okay, like a loop. Okay. Okay, that's all.
In physical form, is the same. If we press the first push button, it will increase, and if we press the other, it will decrease. If we continue decreasing, the counter will reach to the highest number. Look like increase and decrease, and that's it.
In practice 3, we'll create a counter on a cathode type display from 0 to 9 and vice versa. That is, we'll make a display that shows the number or from 0 to 9 in ascending and descending order. For this, we'll do a bit of the same. We go to MCC, CPU, external clock, 16 million hertz. And the same, it's an automatic code. So this meaning that it doesn't require any input. We'll just select ports D to 0 from 0 to 6 and to the output, okay, without name, okay. Now the code will change little by from start the how to say, in addition to having a delay, this will be 500 milliseconds, but for Proteus we only have 50 on this, okay. We'll have to add two arrays, the I, which will count the counter time, and the counter, okay. Next we'll create a third array called value, that here, okay, and to each number with a code combination. For example, in the case 0, the value will be 0 for 0x3f. In case 1, value will be 0x06, and all of the numbers from 0 to 9 for all the values, okay. Once we have this, now we can start with the code. From start, port D, we assign the port D to display the counter, in this case. Then we configure two for loops, okay. And the first four will set the I to 0, to which will increase to 9, as this is our maximum number, okay. Displaying the I from port D and showing the numbers on the display, okay, which the newly selected delay, okay. After complete the loop, we'll go to the second for loop, which will indicate that the I will now decrease to 0, so that the display goes from 9 to 0 in this case, and with the same delay. And at the end of the two for loops, the I is reset to 0 to start the loop again, okay. So this is the result of the for loops. Now in Proteus, we simply place the mega and a cathode type display, this here. It can be connected to only one resistor, but in this simulation I will connect with 7 resistors and with the ground, okay. After placing the L file, okay, here, we can start the simulation, okay. You can see how the counter increased to 9 and then decrease to 0 to start the counter again.
In the physical version, it does the same thing, okay, here. And now with the actual half-second delay, you can see that the display shows the numbers from 0 to 9 and from 9 to 0. And it's going to loop it.
For practice 4, we'll use the same sketch as the previous practice, but with different code. We'll display our full name and license plate. For this, we'll leave the MCC and the Proteus configurations the same meaning. We won't change anything, okay? But now, in microchip, we'll make 6 different arrangements, each one with their respective combinations for a display, okay. That display show correctly the name and license plate numbers. From the first three arrives are for the name and the last name. The fourth arrangement will be for the license plate. The five, this is a part for me, but this is to create a long dash before displaying the next arrangement. And the six, well, that is the seconds count. Okay, starting the code will be specific that port D should display the name to begin with, taking into account the seconds counter arrangement, okay, with the delay. Then in the while loop, we use a for loop to count the counter from 0 to the number of letters that our name contains. In my case, my name has 6 letters, so I will reach to 6. Obviously, with the counter, we'll adding one by one, and the 4D will display the num with the arrangement counter. Next, with the delay that will be selected in the start. Okay. Then in afterward, the counter will automatically return to 0 again, and we begin another for loop. And here, to insert the long dash, that will indicate the next step, sorry, the next sequence, the Saiga rave and the delay. Then we'll be repeat the same steps with our last names, okay? With our last names and our license plate, respecting the for loops and placing the brackets correct, okay? Once the code is finished, we check if it's correct to we'll proceed to Proteus. Okay, there's no fail, there's no worms, so we can go with Proteus. Okay, and here, well, this is the same with Proteus, so only load the file and we can start. Okay, now in Proteus, we add the code to that mega. Okay, for start the simulation, and this is the name, the middle name and last name, and the license plate. Okay, and then start the loop again.
Well, this is the physical format of the circuit. It looks like this with a half-second delay, showing my first name, my two last names, and finally my license plate. To start again with my name.
For the last practice, number 5, we'll create a functional traffic light that is with two series of true LEDs. We'll create a small traffic light that change at a certain time. To do this, we'll go to the MCC and see the external clock for start in CPU. Then we'll specifically 6 output ports on port D, specifically from 2 to the 7. And now we'll need to assign names to the ports. Okay. Since we'll work with each one separately, we'll simply specifically the colors green, yellow, red, the first traffic light, and green, yellow, and red from the second one. Okay, when these are specific, we'll generate the code and here, and we go to the microchip. Okay, from start, the delay, set the delay to 1 second, but for the Proteus, we're going to change this from 50. Okay? And here we only generate one array, which one is the I. That says, so we start with a for loop that goes from second 0 to second 26 in this case, okay? And the I will be increased gradually every second, okay? For the first if, will indicate that if the counter, in this case the I, is from 1 to 5, the first traffic light will keep the yellow and red turned off, okay? And the LED green will be set on. Then in the second if the counter is from 6 to 10, the first traffic light will keep the yellow and red off, but the green will be toggled, okay? Will begin to flash. Then in the next if, here, if the counter is from 11 to 13, the LEDs from the first traffic light, the LEDs green and red will be turned off, and the LED yellow will be set high, will be turned on. And if the counter is after the number 13, the yellow and green LEDs of the first traffic light will remain off, and the red LED will be on. Here, will be set high. And this until end the loop. Then, for the second traffic light, will indicate the following. That is the same, really. If the counter is between 0 and 13, the green and yellow will be set off, and the red one will be set on. Next, if the counter is from between 14 and 18, the LEDs red and yellow will be set off, and the LED green will be set on. Okay? Then to the next if the counter is between 19 and 23, the same, the LEDs red and yellow will be set low, and the red green will be flash, as mean the LED green will be toggled. And to end, if the counter is next to 23, the LED yellow will be set high, and the LED red and green will be set up. All the four will be indicated with the delay that was marked at the first day in the beginning, okay, in the beginning. And that's all. Next, we have to copy the code. That's correct. And now we have to Proteus. We load the code in Proteus, and in this, we have to connect the ports D and the LEDs. And the LEDs, we have only different colors. You see the LED green, LED yellow, LED red, and in the other traffic light. Okay, we're going to simulate this. Okay, the green star toggle next to yellow, and the red appear. In the second, the green is toggle, the yellow and red, and that's all.
Physically, by setting the delay to 1 second, you can see that the specific time for each loop is 26 seconds. So the green LED will be on for 5 seconds. It will start flashing in the next 5 seconds. The yellow LED will be on for 3 seconds, and the red LED will be on for 13 seconds until the loop ends.